Hi everyone, this is a test device that I've been working on that I put together actually years back, but just recently I pulled it out and I've put these two inductors on it, two coils with a steel lamination core inside of each, which is both identical size, both coils are identical. TinMan has suggested a test and I'm going to test it with this device here because I've already got it set up, so it's pretty simple. And I will show you possibly what TinMan was suggesting. If it wasn't the right thing, then whatever, you'll see what this test does. But let's begin. So at the bottom here we have the coil, and I'm going to use a circuit that I have here that I can just control a pulse. So I can give it exactly the identical pulse every time. And basically, I can only get this circuit down to about 4 Hertz. So to get one pulse, I just attach the positive terminal just for an instant, and I hope that I get it at the beginning of a pulse. It might miss, but usually it works, and it'll just give one pulse, and I let go of the basically the contact there. So it works in most applications. So what Brad was suggesting to test is basically when you energize a coil and you have another coil above, that there is a certain amount of attraction that will happen, the cores. And then if you put that core, this one here, the above one, not the one you energize, so this one could be considered as the secondary, under load, in my case, I'm just going to short circuit it. So I've added a little switch here where I have a wire here, this yellow wire here. Basically, when I flip the switch in that position, this contacts and makes a short circuit. So short circuiting a coil is putting the coil under most load. I'm not going to use a load resistor because this shows the effect better. And then in this center position, the coil is open. And what I'm going to do, a bonus for you, is I'm going to show you by adding a diode, short-circuiting the coil through a diode, what that will do. So you're going to be able to see both at the same time. So let's begin the test. And what we have is we have this falling. See, if you look at the edge of the coil here, it follows pretty well always where the beginning of this core, the bottom core, is. So that's where it rests, okay, normally. So I've got a balance to do that basically. So now I'm going to give one pulse, and we'll see the distance it travels. And basically I have this here, this board here, and it should hit that. So here we go, one pulse, and it hit the board. I'll stop it now. I've just stopped it with my hand. And I'll give you one more shot of that so you can see the distance traveled. Okay, so you can clearly see that it touches this board. So now we're going to put this top inductor here on load. So now I flip the switch. So basically now I have a short circuit. And we still have our alignment there. So same thing. Now we have a short circuit, basically the most demanding load on that coil, and that would represent a secondary of a transformer. So now we do the same pulse, and as you see, it cannot travel as far. So I'm just realigning that again here, making sure that we're comparing the same position, identical position. So there we are. I'll give that one more power stroke, and that's as far as it can travel. Okay, so now I will short circuit the coil through the diode. So I flip the switch onto the other side and make sure we've got our same alignment here. Okay, we are aligned, and here we go, one pulse. Oh, that was interesting. It seemed to even push the board further. So one pulse coming up, And there you go. Maybe that pulse is just a little less because of the timing of the, I'll just do it one more time. Yeah, so there you go, it hit the board again. So there you go. Hopefully this test is meeting TinMan's test requirements. If not, sorry. Thanks. Bye now.